In this video, I will be creating part of a Boeing 747. If you have seen my previous video on the creating a basic plane or complex plane like the Boeing X-32, in SOLIDWORKS it is similar to that, but will work with the 747, and I will start by doing only half the plane, and then reflecting it all over a plane. I will also start out by doing only a fuselage, and then adding on the wings and tail sections onto the fuselage, as opposed to more organically trying to create a unified shape with the X-32. So first you want to download an orthographic image of the Boeing 747, which I've done here, and then you want to create 3 copies of it. And I'm just going to name them top view, front view, and side view. And then you can open them in Paint and edit them as such. So for the front view, we will want this section here. Broadly select it over it, crop out. And crop it like that. So I'll save that, and then move on to the next views. The side view is this one in the top left. Just trying to find out the max corners I can do to shave as much off of it as possible. And you want to, it's helpful to start from both corners and then crop from there. And finally onto the top view. Once again, I will start from the bottom right corner and crop to the top left, trying to fit in a very tight box. And now that I have all 3 of these edited, I will open them all again with Paint to double check that their pixel length and heights are all matching up with each other. So if you look at the coordinates down here, as you move your cursor, you can see that the first one is the length in the X direction, and the second one is the height. And so we're going to base the top view on the other one we're going to edit. So it's 902 long from front to back, and the wingspan's total is 822 pixels. So we want to go to here, verify that it is 902 long, which it is, and verify that this one is 822 wide. But it isn't, so we are going to edit that. Make sure to uncheck this, 822, and save any changes. And here we can see the height is 231 pixels, so we want to replicate that here. And 231, and save the changes, and now we have something to work with for SOLIDWORKS. So I'm going to go to the side view for now, and mark off which sections are the wings, because we want to avoid creating those in the next step. We only want to create the main fuselage body. We will also be ignoring the tail sections here. So we're just going to create a red line highlighting just to kind of remind us not to use this. Doesn't have to cover the whole thing, just enough to let you know to ignore it when tracing out the lines. And I will do a similar process on the other ones. I'm going to refrain from closing these files so that I can undo these later and clear them up. And on the front view, we're really only using the oval shape here, sort of egg shape of the fuselage. And so in SOLIDWORKS, go to Part, and go to the Settings, Document Properties, and change the units to millimeters, grams, and seconds. And we're going to change this over to meters once we are creating the airfoils. And here we can see the planes and the origin. And we want to make sure to remember this origin as we will be orientating ourselves with it. We want to picture the origin as the essential value that is basically in the top left corner of all these images. So if we are going to create a block down, we want to make sure it goes down in the Y direction and basically fits in the corner. So we're going to create a sketch in the top plane. And so this top plane corresponds to the top view here. And so we want to create it 902 long. So line 180 degrees. And for reasons I will get to later, I will only be covering half the wingspan from here on out until a later step. So we will have this and get 411. If your numbers are slightly different, that's fine. And it's going down in this direction. Remember to make it the corner of the picture. And then close these sketch lines to form a rectangle, exit sketch. And now we have our first rectangle. And we want to extrude it downwards, 231 millimeters. And we want to reorient ourselves with standardized trimetric view. So we have this YZX configuration like so. And we will extrude this down the height, which is 231. And double check our origin is in the right place, which it is. And I'm going to mark this plane out in green to remember it as the reflection plane. So now we will go to the front view sketch and basically try and create an approximation of the egg shape here, like this green line. So we can see it starts we can look down at the coordinates in the bottom left and see that it starts at a height around 121 pixels down. Start a sketch on this plane. Create a point on this line here. And going to this corner over here, we can see it is at 369, 176. And the bottom point is at 410, 218. But again, we're going to create that on this line, so we're only worried about the height number of 218. Almost at the bottom, but not quite. And now we were going to create more points approximately in these spaces here. And so we go back to the sketch. And we will create one at 381, 140. .381 and 140 from the top. And just looking at a arbitrary point here, we see 388, 212. And now with that done, we can create a spline curve connecting all these dots. And then escape after the last dot, and exit sketch. Well, actually, before we exit the sketch, we want to encircle all the blocks here that do not include this gray space here. So we're just going to go out and then sweep around it with these lines. Oh, it appears I accidentally started creating a circle, but that's fine. And exit sketch. And so now from this we can make an extruded cut and through all checkmark. And as you can see here, we still have the green space. If you wanted to, you could also just kind of try and do the spline curve on your own after creating these three broad points. Just sort of eyeballing it, and then we'll reflect over in the next step so you won't have to repeat the exact dimensions on another step. We can see here that the nose cone is centered at a height of 177 pixels, and that is down from the origin, not the top of the green space here. We're orienting from here. And it curves, ends at 55, 142. Then hikes up in a line to 67, 130. And we're going to curve it back till we reach here, which is at 117, 122. As you can see, it's just within the green line here. And head straight back till we reach 286. And we'll just create it on the same y value. And then proceed in a straight line down to 383, 134. Then still heading backwards, you can see here where the red lines start to obstruct, but if we remove them, we can see that for the most part, it continues in a straight line back to here at 771, 136. And 136 approximates 134, so we're just going to create that on the same y value. So scroll down, make sure these blue dots line up. And 758. I'll go with that as the x. Then 833, 131. And then to 872, 130. Then it's going to arc back to 882, 143. Then 871, 160. And then in a line straight down to 575, 220. Delete that. And we will proceed forward to 129, 281. Sorry, that should be 220. And still on this bottom line. And I will then create a roughly midway point here at 53,205. And so now I'll connect these sections using straight lines. And we now have our fuselage shape. However, if we look at the sketch here, we can see there's a more curved aspect in these sections here. So we want to fix that a bit. I'm going to approximate using the spline curve tool. And so now I have a spline connecting these 2 points, and I can delete that. And I go back to the sketch, and I want to create a spline more like this. And then escape, and I can delete these 2 lines. And same here on the bottom. Press escape and then delete that line. And now create a large rectangle surrounding the entire block and exit the sketch. And as you can see, it's blue here, which is good. And so we're going to select extruded cut and through all again. And as you can see, it's starting to approximate the shapes we're wanting. And so now we will go to the top view. And remember, this point here corresponds to this point here on our SOLIDWORKS model for now. We're going to reflect it all over the green plane later. So again, in relation to the origin, we will create a point at 12,397 on the top viewing plane. And then at 116,372, and then at 163,367. And we want to make sure that's inside our gray lines, but it isn't, so we need to increase it slightly. Go with 371. Yes, and now it is. But maybe I can lower that down to 370. Again, these errors are mainly coming from the very rough job I did cropping out the boxes. And so from there, we're going to proceed in a straight line back to an x value of 648. And so we want those blue dots. And 648. And so then we'll go to 761, 381. And so again, we're going to meet in the middle and just create another straight line from the point we just created to the very back, which is at an X value of 882. And so it will be on this line here. And as you can see, it lines up well, so that's a good sign. And so now we connect the dots. And if you want to create any spline curves to even out these curves to make it more aerodynamic in any simulations, you can. And I will do that right now, real quick. You can also do this process just by going smaller steps along the curve line and then using straight edges. And so create a giant rectangle around all of that, exit sketch, then go to extruded cut through all, and OK it. And so if we go to a trimetric view, we have this. So now is the step where we will create the wings. And as I mentioned earlier, we're now going to switch the document properties to meters. This is just because it makes it easier to load in the airfoil shapes. So for the Boeing 747, this is a good approximation of its airfoil, the Whitcomb Integral Supercritical Airfoil. You can look this up on airfoiltools.com, and if you haven't seen my previous videos, go to CLIG format DAT file and copy all of this. And now we'll be going over these steps again on how to create an airfoil in SOLIDWORKS using the CLIG data. Alright. When you're copying this into an Excel document, you want to just ignore the name. After that, go to Data, Text to Columns, Next, and select Space. And finish that. And now you can move all this data over to A1 for its starting points. And real quick, we're going to make, if you look here, you can see that the plane we want the wings to be created on is the XY plane. So we can set all of our Z values to 0. And column-wise, these are in the right spot. Column A being X and B being Y. That's the easiest way to do that is just hit 0 and the down arrow real quick sometimes on there, and then can copy and paste down several times. And you can copy larger swaths and then delete any overhang. After that, you can save the document and then export. We will do this by doing Save As, and then select the type, go to Text, Tab Delimited, and Save. And we want to make sure all the zeros share the same tab alignment, as well as the previous columns, which they do, so that's good, and we can proceed. I have already created the NACA 0010 text. It's the same process, just search the NACA 0010 on airfoiltools.com. Then in SOLIDWORKS, go to Curves, Curve through XYZ points, Browse, go to the folder where you have we're going to start by creating a sketch on the front plane and convert entities. Can select the edge and the check mark, zoom into the back of the airfoil and finish the sketch off and make sure we get this closed gray shape. After that's done, you can then highlight the sketch and copy it. And we're going to rename this as root wing and make another copy and rename it tip wing. And for now we can then hide this sketch. And so we're going to edit the root wing. If we go to the sketch on top view, we can see that the wing goes from about 268 to 468, making its length 190 pixels or 190 millimeters. So, in order to edit that properly, we will then go to Sketch Tools, Scale, select all the entities by highlighting them, scale about the origin, and use 0.19 as the scale factor. And if we move over to this plane, we can then do the next step, which is to move it. So, I want to create a dot roughly in the center, and we want to put it 268 millimeters behind the origin. So that's 0.268. Tools, Sketch Tools, Move, highlight all these entities, and move from the origin to the point here. Then exit sketch. We are then going to edit the sketch plane from the front plane to this plane. And we can see it worked. Now for the tips of the wings. We can see here that the sweep angle is slightly variable, but I will only Here we can see that the sweep angle is variable, but I will treat it as constant, simply as a matter of simplification. We can see here that the tips go from pixel 586 to 639. That is 53 millimeters, and again, 586 is our starting point. So create a sketch on the front plane. We also want to make sure it aligns with our middle point here, but it will be farther back, 0.586. So we're going to edit the tip wing sketch. We want to align the dots with the airfoil we created in our previous example. and then 0.586. Escape that tool, and then highlight all entities, tools, sketch tools, scale. And our scaling factor will be 0.053. And we will scale about the origin again. Highlight all entities, tools, sketch tools, move. And moving from the origin to this point here. We can now hide this curve. And we want to create a loft between the two sketches. And that was successful. Now we are going to create the tail section. For this, we're going to use the NACA 0010, even though it is not listed as a specific airfoil for the Boeing 747. And we're just going to extend these lines so that we know where they might intersect with the central axis of the plane. So looking at the width, the horizontal stabilizer will go from 737 to 862. That is a width of 125 pixels at the root, again starting at 737. So I will go to curves, curve through XYZ points, browse, and then load up the prepared NACA 0010. And again, it should be 1 meter long. So I will convert the entity and then finish the sketch by using straight lines. Exit that sketch, and then create 2 copies of it. And we will rename them to root tail and tip tail. So first we will edit root tail by a similar process of highlighting all the entities and scaling them down. The scale factor here will be 0.125, and we'll scale about the origin. We also want to create a dot and approximate it with the central region here, in height anyway, and we will place it 0.737 meters back from the origin. We can then go to Tools, Sketch Tools, Move, highlight the entities, and starting from the origin, move it to our created point. Then exit the sketch. However, this creates the root tail back here, and we want it on this plane here, so we just have to edit the sketch plane, deleting the front plane and selecting face 1. Now to edit tip tail. If we go back to our sketch, we can see that it starts at 866 in the X and ends at 900. This produces a length of 34, and again starting at 866. So, editing the sketch, we will highlight and scale down. The scale factor will be 0.034, scaled about the origin. And we want that point aligned vertically, but in the X we will change it to 866, or 0.866. So first you want to delete that coincident constraint, and then go 0.866. And we don't have to worry that it's out of the plane right now. So highlight everything, tools, sketch tools, move, and starting from the origin, we then move it to this point here. Hide the curve and sketch 14. And now we want to create a loft between these two. Although actually first we need to edit our sketch plane slightly. We can see here that the plane is at a value of 268 or 265 from the origin. So we're just going to copy tip tail over so that it comes up after that. And edit the sketch plane. So we could then create a loft. Gonna clear these selections. And now the vertical stabilizer. We can see here that the horizontal stabilizer is slightly higher than the wings, as it is in our sketches. The vertical stabilizer will be done in a process similar to the tail. In order to create a mirrored surface, we want to create a plane version of this here. So I just named it plane 3. And then go to mirror, make sure to go to bodies to mirror, select your plane, then as the mirror face plane, choose plane 3, click the green check mark, and now you have a mirrored plane version. And now we can create the vertical stabilizer. However, we will want to adjust the plane the airfoil is created into the XZ plane, meaning the Y will now have all the 0 values. So we are going to create another Excel document. go to Data, Text Columns, and select Tab. We then want to take the entire B column, move it out of the way, move the C column to B, and then move this one back to where C used to be. We can then save it and save as a tab delimited file. We'll then close our notepad and Excel docs. Then curve through XYZ points. Now back to our sketch planes. We can see that the vertical stabilizer starts at an X value of roughly 688 and ends at 852. This makes the length 164 millimeters, and again starting at 688. So we're going to create a sketch like that on the top plane. We'll then edit that sketch plane to one of these two here. Make sure to highlight the top plane before copying and pasting the XY sketches. We will then rename the sketches to root V and tip V. Now to edit the root V sketch. Highlight everything, tools, sketch tools, scale, scale about the origin, and we will use a scale factor of 0.164. And we want to move the starting dot back 0.688 meters. We can then move the sketch there. And exit the sketch. We will then edit the sketch plane from the top plane to here. And we will then edit tip V. Back to our sketch, we can see that it goes from 852 or 854 to 900. We will go with a scale factor of 0.046 for that. So go to Tools, Sketch Tools, Scale. And smart dimension it, so it's at 0.852, sorry, 0.854. And then move it using the sketch tool. and we will leave it in the top plane. We can then create a loft between the two. And now we have a finished approximation of a Boeing 747 plane.